Now that we've had the chance to get our practice back and get better at solving equations, inequalities, and proportions, now we're going to move on to the next step, which is that graphing of linear functions. But before we can really start that, we need to actually start with some definitions. We know what a function is. We learned about that in chapter 1. A linear function is going to be that function that has a constant rate of change, and we can rewrite it as f of x equals mx plus b. Now this should look familiar to you because you saw y equals mx plus b when you were in Algebra 1, and this is exactly the same thing, except now we're referring to them as functions as opposed to just equations of lines. Now if you recall, slope is that constant rate of change for a linear function. So if it is linear, it's going to have a slope, and the ratio of the change in f of x to the change in x, or your rise over your run, which I've noticed in talking to you guys, that's not a problem with most of you. Now our x-intercept, recall, is the x-coordinate of the ordered pair at which the line crosses the x-axis. And this is going to be, if you recall, think of it in terms of this is that x value when y equals 0. Now, our y-intercept, likewise, is the y-coordinate of the ordered pair at which the line crosses the y-axis. So this is going to look in the form of 0, comma, y, where that y value is that intercept. Now, just to help you out, I've got an additional picture for you to help you out. Remember, y-intercept is going to cross the vertical axis, and x-intercept crosses that horizontal axis. Now finally, we have slope-intercept form. And slope-intercept form is that y equals mx plus b, where m is the slope and b is the y-intercept. So now that we've got all of our definitions, let's go ahead and take a look at some of the things that we need to be able to do for today's lesson. So the first thing I want to take a look at is when you're given a graph of a function, I want to know, is it linear? And so we need to be able to explain why or why not. So if we take a look at this first example here, we have x values of 2, 5, 8, and 11, and f of x values of 9, 17, 25, and 33. So the first thing that I want to take a look at is what the values change by. So if I go from here to here, I see that 2 to 5 is a plus 3. 5 to 8 is also a plus 3. And 8 to 11 is also a plus 3. So that means if this is going to be linear, which we remember linear functions have a constant rate of change, that means that our f of x values should be increasing by the same amount. So from 9 to 17, that's plus 8. 17 to 25 is plus 8. And 25 to 33 is also plus 8. Oops. So therefore, I would say that yes, this is linear. And you can just say that there is that constant rate of change, or ROC, as I like to refer to it. Another way you can take a look at, because this is going to be a constant rate of change, and you might want to emphasize that this is a rate of change of 8 over 3. Remember, f of x goes on top, x goes on the bottom. Let's take a look at the next example here. We have x values of 3, 9, 15, 21, and f of x values of 1, 4, 10, and 19. Now when I look at this one, I see from 3 to 9, that's up 6. 9 to 15 is also up 6. And 15 to 21 is also up 6. So that means the f of x values should increase by the same amount. From 1 to 4 is plus 3. From 4 to 10 is plus 6. And 10 to 19 is plus 9. Now while the amount that it changes by in f of x from each increment is an equal increment that from 3 to 6 is plus 3 and 6 to 9 is plus 3. It's not consistent across the board. So this one would be not linear. And you could say because, I'm saying B/C for because, f of x change is not constant. So basically that's what we need to look at, that change in f of x over the change in x. If it's consistent, then we're good. Because if you look here, this change is 1/2, this one is 1, and this one is 1 and 1/2. And so that is not consistent, so therefore it is not linear.